Hi students, let's look at how we apply the change of base formula for logarithm and also how do we derive this formula here. So this is actually quite a useful formula because you are given, if you ever want to change to any base other than a, whatever base you're given, you could actually use this formula here. So let me just explain how this works, okay? So for example, if I have a log base, let's say 5 and I have 15, I guess, okay? And I don't really like the base of 5. And I prefer the base of, say, base of e. So base of the natural constant e, log e, and I could just write this as log e and log e. And what I need to do is to plot the 15 on top here and plot the 5 down here. So the one on top, put on top, and the one below, put below. And I could just write this as ln 15 over ln 5. All right, so it doesn't have to be log e, it could be anything. So for example, if say I have log 11 and this is say 20, and I don't really like the term here, so I could just say use log 2, base of 2. It's just my natural preference. It doesn't have to be log base of 2, it could be any random number. So it could be let's say it could be just 6, log 6 20, and log 6 11, and so on. Okay, so many usage for this formula here. We'll use it quite often as well in our exercises, so please practice it. It's quite useful, the change of base. So let's see how we could actually what do you call it, prove this this change of base formula here. Okay, let's see now, but before that we could actually try and write a special case here. Special case would be when say you have log base of a b, right? Log b base of a, log b base of a. Now this is the base of a, so what happens if I were to interchange the base? So meaning to say, if I change it to base of b and change it to base of b, as such, this b will be plotted on top, this a will be plotted below, log bb will just be 1. Okay, so this is a special case of logarithm. So here will be log ba. So this is a special case where if you want to flip the base, you just need to reciprocate it. Remember to add a 1 and divide by 2. So meaning to say, let's say this is log 7 5. This is similar to 1 over log 5 7. All right, so that's how we use the change of bases. Now I'm going to proceed to prove this. This is quite fun. So we're going to let the proof how come this works, right? So we're going to let log a let y equals to log ab. Okay, then naturally, once we have this logarithmic function here, we're going to just change it to the exponential function and try and understand what's going on here. So this is log, this is b. Okay, now what we're going to do next is actually quite simple, because now what we need is actually log c, right? So we just log c both sides, both ends here, log c both end here, this end and this end here. All right, so once you've done the log c, this is the interesting part. So we have already learned the power law. So the power law, we just bring this down, and essentially this would just mean that this rule will just bring it down, and what we'll get is log cb here, and this will just be y log ca, log a base of c, log cb. Now the c could be anything. Okay, so basically I just take the log base of c both sides. So I take log c both sides. Okay, so this is what I'm doing actually. So I'm just gonna logarithmic function it both sides. So this case here, I want to find what's my y. My y will just be equal to log cb over log ca, and y would just be log ab. All right, so log ab is equals to log, that's the initial. So that's how we derive this formula here. So I hope this actually helps you to understand how this formula is being derived. It's good if you could understand it step by step. It's not really required of you to know how to prove it, but if you know how to prove this, is really good for your learning as you proceed to higher level, like A levels. Yeah, just keep practicing and I'll see you in the next video.